In this video, I'm going to explain different formulas, units used in CAMS. So the units, the linear displacement is measured in meters, angular displacement in degrees or radians, velocity in meters per second, acceleration meters per second square, angular velocity radians per second, angular acceleration radians per second square, lift of the follower, that is in the meters, and pressure angle in radians. So frequently these are the terms are used in the CAM chapter, that is the linear displacement or displacement of the follower, the angular displacement of the CAM, what is the velocity of the follower, what is the acceleration of the follower, what is the angular velocity of the CAM, angular acceleration of the CAM, pressure angle. These terminology are frequently used in the CAMs. Once you are familiar with these units, it's sufficient for this CAM chapter. Now let us go for the formulas. CAM profile equation. So in CAM profile, you can use this equation, you can develop the CAM profiles. That is the equation y is equal to a0 plus a1 theta plus a2 theta square plus a3 theta cube. Y is the displacement of the CAM follower in mm. And theta is the angle of rotation of the CAM in radians. A0, A1, A2 and A3 are constants. And second formula, CAM lift equation. So lift of the CAM that is obtained by using this equation, L is equal to R plus D minus R cos theta plus square root of L square minus R square sin 2 theta. So where this L is the CAM lift and small r is radius of the CAM, small d is diameter of the CAM follower, theta is angle of rotation of the CAM, and L is the distance between the center of the follower and the center of the CAM. So use this formula, you can find out what is the lift of the CAM. Next, third formula, CAM velocity and acceleration equation. So the CAM velocity, once we know the displacement, so you can derive the displacement equation, you can obtain the velocity. That is V is equal to dl by dt. And CAM acceleration, further differentiating that velocity equation, you can obtain the acceleration. That A is equal to d square L by d theta square. Fourth formula is displacement formula. So D is equal to capital R plus small r into cos theta minus square root of L square minus R square into sin square theta. Here where the capital D is equal to displacement of the follower, capital R is equal to radius of the base circle of the CAM, small r is equal to radius of the follower, theta is equal to angle through which the CAM has rotated, L is the distance between the follower center and CAM center. Fifth equation, velocity V is equal to R into omega into 1 minus epsilon square by 1 plus epsilon minus 2 epsilon into cos theta. Where V is equal to velocity of the follower, small r is equal to radius of the follower, omega is equal to angular velocity of the CAM, epsilon is equal to eccentricity of the CAM. Sixth equation, acceleration, A is equal to r into omega square into epsilon into sin theta by 1 plus epsilon minus 2 epsilon into cos theta. Where A is equal to acceleration of the follower, r is equal to radius of the follower, omega is equal to angular velocity of the CAM, epsilon is equal to eccentricity of the CAM. Pressure angle, psi is equal to tan inverse r into sin theta divided by capital D minus small r minus r into cos theta. Where psi is equal to pressure angle between the follower and the CAM, small r is equal to radius of the follower, theta is equal to angle through which the CAM has rotated, capital D is equal to displacement of the follower, capital R is equal to radius of the base circle of the CAM. Velocity and acceleration diagrams when the follower moving with the different motions. Now you can see in the tabular form how we can obtain the maximum velocity and maximum acceleration of the follower when the follower is moving with simple harmonic motion or moving with uniform acceleration and retardation. Now let us see that. First one is the first row indicates the simple harmonic motion. Follower is moving with simple harmonic motion in outstroke. Then maximum velocity is obtained. V naught is equal to pi omega s by 2 into theta naught, where theta is the angular displacement of the cam during the outstroke. S is the stroke or lift of the follower. Now you can see that what is the maximum velocity during the return stroke. The VR is equal to pi omega s by 2 theta. Only the difference is angular displacement during the return stroke. Only you can replace. Remaining formula is the same. Now let us see that what is the maximum acceleration when follower is moving with simple harmonic motion during the outstroke. That is a naught is equal to pi square omega square into s divided by 2 theta naught square. Now let us see that in the velocity equation. Now let us separate s by 2 into pi omega theta naught. S by 2 into pi omega theta naught whole square, you can obtain the acceleration equation. Likewise also you can remember the formula. Now for the return stroke, only that theta is changes, remaining is as it is. So instead of a naught theta naught, you can put ar theta r. That's it. Remaining terms are same. So ar is equal to pi square omega square s by 2 into theta r whole square. Similarly, for uniform acceleration retardation during the outstroke, the velocity is v naught is equal to 2 omega s by 2 theta naught. In return stroke, 2 omega s by 2 theta r. Similarly, for acceleration, a naught is equal to 4 omega square s by theta naught whole square, and ar is equal to 4 omega square s by theta r whole square. So these are the formulas. Once if you know the formula, you can easily find out what is the maximum velocity or maximum acceleration of the follower during the outstroke or return stroke when the follower is moving with simple harmonic motion or uniform acceleration and retardation. I hope all of you understand what are the formulas and their units used in the CAMS.